Hello everybody, I will start my today's another live coding session. So in my today's video, I will solve this question. Merge sorted array. So I'm given two integer arrays, nums1 and nums2, sorted in non-decreasing order, and two integers, m and n, representing the number of elements in nums1 and nums2 respectively. Okay. Yep. And merge nums1 and nums2 into a single array, sorted in non-decreasing order. The final sorted array should not be returned by the function, but instead be stored inside of the array nums1. To accommodate this, nums1 has ranks m plus n, where the first m element denotes the element that should be merged. And the last n elements are set to 0 and should be ignored. Nums2 has a rank of n. Okay. Nums1 has a rank of n plus n. I see. So originally it's set to 0 first for the latter half. Okay. So firstly, let me understand my question, this question clearly. So in this question, the input should be nums1 array and nums2 array. Yeah. Both of them are integer array. And output should be nothing. But this should be mutated. Yeah. To store. Yeah. Of the element from nums1 or nums2. And yeah, it should be sorted. Okay. And something it says here is that nums1 should be something like this. So the latter half, which is for nums2 space, are, filled in with 0. And yeah, these nums from nums2 should be stored in this space. Yeah, obviously in a sorted way in total. Okay, good. So okay, so that being said, I will think of an example. So right, nums1 is 1, 3, 5, and nums2 is 2, 4, and it should be 0, 0 here for plots for numbers from nums2. Okay, so I think the most obvious and kind of brute force approach is that put numbers from nums2 to nums1 in the zeros slots, and it becomes 1, 3, 5, 2, 4, and then sort it. Yeah. Okay, so in this way, the time complexity should be firstly O of n to move numbers from nums2 to the slot 0 slot in nums1, and then I have to sort it. So it looks like this. Yeah. But I think I can speed up. So I think instead of this, I can use the 2 pointers. So I would say this is index 1 for index in nums1, and this is index 2, pointing to the element in nums2. So I will compare this nums1, I1, and nums2, I2. And when nums1 is okay. Yeah. I think I try to create a merged list. Yeah. So I will append element from nums1 or nums2, and I use the 2 pointers, moving I1 and I2. So if I1 is smaller, I put I1 number here, then move the I1 pointer. If now I2 is smaller, I2 number is smaller, I put I2 number and then move the I2 pointer. And now I1 number is smaller, so I put 3 into the merged list and I move the I1 pointer. Yeah. So and I will do that until nums1 reaches scans all the M elements, and then I have the merged list. Now it should look like 1, 2, 3, 4, 5. So I point the nums1 array to this merged array. Sorry, I point this nums1 variable to merged array. So I think this is a possible solution. But I have 2 concerns. So number 1, I created another array which takes extra space, n plus n. And concern number 2, is it really okay that nums1 is now in the end not pointing to the original array, but a new array? Yeah. I will write it down. So and I think for concern number 2, it is easy to fix, because if number 2 is not allowed, I just have to, move. I should say. So each element. Okay, so I just have to use the 2 pointers for nums1 and merged1 again, and I copy the element from merged array into nums1 pointer position. Yeah. So I think this can be easily handled. And this one is my more concern. Yeah, I'm pretty sure this is not allowed, because the caller of this merge method, don't have access to nums variable. What should I say? Actually, the caller just has a pointer to this list. So I think this has to be handled. I will do that. And I will think how I can, how I can save this space. So one thing I can do in my quick idea is I will create the nums1 copy array here and do the same thing. And nums1 copy should have 1, 3, 5 only. Then instead of this merged array, I update nums1 array. Yep. So in this way, the space complexity extra should be now O of M, because I created the nums1 copy array. Yeah. Okay, so I think that's I mean, approach I can optimize it. Maybe let me quickly check one more idea about another approach. My another approach is put nums2 numbers into nums1 array in this way. And I use 2 pointers like this. Mm. Ah, no, sorry, it doesn't work. I was just thinking using the reader pointer and writer pointer. But probably it doesn't work. Yeah. I mean, like this. Mm. When I swap 2 and 3, it's okay. Yeah, but yep. Okay, so I try to think of the implementation or algorithm to use extra constant space only, but I didn't come up so far. Let me go with this idea. Okay. So I will quickly sort out the process. Create nums1 copy. Then use 2 pointers. And update nums1 on reset. Okay, now I will implement this. Oh yeah, it says modify nums1 in place instead. Yes. Yeah. This actually create another array. Yeah. So it works in this way. And I will use the 2 pointers. This is actually M and N. I can use that. If I1 is equal to M, I copy nums1 element to the merged array, which is actually nums1. So let me call it merged index. Like this. And in this case, there's no element in nums2, so I choose nums1 element. Okay. Sorry, so let me change something here. This is quite confusing in terms of the implementation to use nums1 or something in terms of the variable names. So let me rename it like this. Yeah. So in this way, nums1 is now pointing to the copied array, and merged list is pointing to the given nums1 array. I think it's much more, easy to understand. Yeah. And let me call it mi, merge index. Good. Sorry, let me call it I merged. Okay, so I merged is nums to I2, then increment I2. And here, I put this and increment I1 plus equal to 1. And next case, if nums1 I1 is smaller, as I said, I will choose the nums1 I1 first, obviously, because it should be sorted in ascending order. Otherwise, I choose the nums2 element. Like this. Okay. And that's it. In the end, I continue until I1 is equal to m and I2 is equal to n, which means that all the elements are now copied into the merged list. And merged list is pointing to nums1, original nums1. So now I could modify nums1 in place. Okay. So as I said, the time compressed D should be O of m plus n, and space compressed D is O of m. Yeah. Okay, let me dry run my solution. I go with very simple one. Yep. So in this case, I expect in the end it becomes 1 to 5. So let me try. So in line 62, nums1 is now it becomes 150 until index 2 exclusively, so it should be 15. For nums2, it doesn't have any change, it be 2, and merged list should be pointing to 150. Okay. And now IM is equal to 0, like this, which is this position. And I1 is 0, pointing to this position. I2 is 0, pointing to this position. Good. And in line 73, I1, which is 0, is smaller than m is equal to 2. And n is 1. Okay, so here I1 is not m, yes. And in line 72, I2 is not n, yes. I mean, I2 is not n, yeah. And then line 80, nums1 I1 1 is smaller than or equal to 2. This one. This is true. So I go to line 81 and merged I m is nums1 I1, which is now 1. And I increment I1 plus 1. Oh, also I have to move mi, im. Yeah, I will do it in the end. Okay. So now index this one should move to this. Now I1 is more, which is 1, is more than 2, yes. And so I go to line 75, and I1 is not m yet, 1 is not 2. And in line 78, I2 is 0, and n is 1. So I go to line 81, and nums1 I1, which is 2, is smaller than or equal to 5. This is not true. So I go to line 85. So merged index 1 is equal to nums2 I2. This is 2. Good. And what happens is that I move I2 pointer. Yes. Then I also move the IM. Good. So now what I would do next is I come back to line 74, and I1, still I1 is smaller than m, so I go to line 75, and I1 is equal to m, no. So I go to line 78, I2 is equal to n, yes. Index 1 is equal to n, so I go to line 79, and merge IM is equal to nums1 I1, which is 5. And then I increment I1, yes. And also I increment IM. And I go back to line 74, and now I1 is equal to m, and I2 is equal to n. So I end the iteration. Yeah, and that's it. And I can find that merged array is now 1 to 5, which is as expected. Good. I passed this test case. Okay, so I covered all the lines, almost all the lines, aside from line 76 and 77. But I'm pretty confident on this part. Yeah. So in total, I think this code is good. So I will submit. Oh, this should be nums2. Good. Great. Okay. Accepted. So, yep, I will quickly wrap up. So today I solved the question merge sorted array, and I was given nums1 array and num2 array, and actually it's the last n slots in nums1 array is a kind of placeholder. Yeah, and I will merge the nums1 array, first m elements, and nums2 array, and I have to mutate the nums1 array internally and store all the sorted numbers into this nums1 array. And my solution is that I use the 2 pointers, basically on nums1 array and nums2 array. But because I have to mutate the nums1 array, I copied the nums1 array into another array and treated it as a nums1 array actually. And original array, I treated it as the merged array. Yeah. So in that way, I could save the space complexity to all of them. And the time complexity is obviously all m plus n because I use the 2 pointers. And pointers, one pointer has to move m steps, and the other has to move n steps. Yep. Okay. So that being said, I will finish my today's coding practice. So by the way, if I find that there is a solution which takes only the constant space, I will, write it up in the description of this video. Okay, thank you so much. Bye.